Joyce, can you hear me okay up there? Does that sound okay? All right, good evening, everybody. My name is Dr. Brian Henning. I'm the chair of the Environmental Studies Department, and I'm very glad to see you here tonight. Thank you for coming. We have a really excellent speaker tonight. But before we get to our main program, I wanted to invite up our local Spokane riverkeeper, Jerry White, to say a few words about the importance of water on our river in Spokane. So, Jerry.
Great. Thank you, Brian. And thank you so much to Gonzaga Environmental Studies Program and to Nick for coming out. I just feel like this is an incredibly important subject, and I wanted to put a fine point on just how important this is for our specific river and our watershed. So we now know that our aquifer depends on all of this snowpack, all of this recharge, and in turn, our river depends on that aquifer for recharge. And in fact, we now know, as of 2015, in that infamous drought year that we had recently, that the pumping we do for our household water and our sprinkling on our lawns and all of that actually can have a detrimental impact on Spokane River flows in the lower river, where we see that recharge during critical low flow seasons. So what that means for us is that this subject matters a great deal in terms of how we're going to adapt so that we have a functioning, healthy river, so we look at our water consumption and we have a beautiful river in 2030, in 2050, and something gorgeous and treasured to hand off to the next generation. So I just kind of wanted to come out and cheerlead how important this subject is, and thank all of you for being here, and thank again Gonzaga for hosting this.
Yeah. So I would encourage you to take a look at our website, Environmental Studies. If you go to gonzaga.edu/environmental studies, you can find an events page. We have a lecture series that's ongoing. This is one of our big events this semester, but we have several more important ones going on. And so please take a look at those and come back regularly for our lecture series. Tonight, we are really delighted to have Dr. Nick Bond, the Washington State climatologist, here to speak with us. Dr. Bond has an abiding interest with the weather and climate of the North Pacific and Western North America. His past research includes documenting the effects of coastal terrain on land-falling storms. His present work involves examining air-sea interactions with tropical cyclones in the Western North Pacific and the atmospheric response to declining sea ice in Alaskan waters. The latter features the collection and analysis of field observations from a research aircraft. On longer time scales and broader spatial scales, he's interested in the causes and effects of climate variations pertaining to marine ecosystems. And of course, as I said, he serves as the state climatologist for Washington. Just so you know, and this was new to me, exactly what the function of the state climatologist is. According to the website, his job is to collect, disseminate, and interpret climate data. The Office of the Washington State Climatologist is called by the state of Washington to serve as a credible and expert source of climate and weather information for state and local decision makers and agencies working on drought, flooding, climate change, and other related issues. So please give a warm Zag welcome to Dr. Nick Bond.
Yeah, thank you. And when you hear that about the state climatologist, you might think I poured on a waffle, right? You know, but before we get started, how many of you know you have a state climatologist? Okay, how many are going to sleep better tonight knowing you have one? Good answer. Some of you who have reserved judgment, that's just fine. We'll see how that goes. So just starting off here with this cartoon that I've gotten a lot of mileage out of since I ran across it a few years ago, and I think it captures the zeitgeist, the mood of the West. There's a lot of things been going on in the last few years. Jerry mentioned the big drought of 2015, of course, the problems with wildland fires, harmful algal blooms with warm oceans, multi-year drought in California and so forth. And how all this relates to climate change is not always exactly clear. And so I think this cartoon has quite a bit of insight to it. I direct your attention to the lower right. You can see where it was published in a place from that hotbed of environmental activism known as Utah. But, you know, I got to give them credit. So, what are we going to do here for the next little while? I'm going to focus on the climate and in particular the water resources here in Washington State. And, you know, what we've seen in the past and what we're anticipating in the future. And with a little bit of a focus on freshwater habitats. Salmon is a special passion of mine, and to a certain extent, agriculture. As we go along here, I would encourage you to ask questions. If it gets out of hand, you know, I got some friends here that'll, you know, put a stop to that process, so don't worry about it. But let's have more of a dialogue rather than a monologue. And so here we go. All right. Back to, you know, we didn't actually plan this, but, you know, back to what it was saying there about, you know, 2015. This is a scene, you know, when the snowpack is typically at its peak at the ski area on I-90 just east of Seattle. We weren't exactly shredding that year, right? And that wasn't just a local phenomenon. Here is a map showing how much water was in the snowpack at the end of winter, typically considered 1 April, different watersheds, different timing and so forth. On the April 1, 2015, all those red colors show where there was 25% or less of the water in that snowpack bank. To the east over the Rockies, they were in better shape, but yeah, they were pretty widespread. A different perspective is just how much precipitation fell that winter as a whole, and there for the water year through March. And all those white areas are where it was basically normal precipitation. So the case was it was a snowpack drought, not a precipitation drought for much of the West. The Southwest also had some precip deficits, as you can see. All right. At the same time, how many have heard of, are familiar with this one I now consider a four-letter word? Anybody heard of the blob? Yeah. Yeah, so that was a big deal. There's going to be a little bit more about that, but we saw temperatures along our and off our coast that were unprecedented in terms of how warm it was relative to normal, and that made a difference in our weather and certainly made a big difference to the marine ecosystem. So just to kind of some of the things that happened that year, and many of you are probably familiar with some of the things I'm going to be talking about. And again, for some of the folks in this room, feel free to speak up and we can have, you know, kind of a discussion rather than just a monologue. But here is an example of an unregulated river in the northwest part of Washington State, the South Fork of the Nooksack. And that blue trace from January 1st in 2015 through the summer of 2015 shows the stream flows day by day on that river. The little gold dots there are the averages for that time of year. And so you can see there were some big flows in the wintertime, early in 2015, when it rained rather than snowed, so the water comes down the hill, right? But then in the spring there, in April and May, that relative to the usual timing, that stream flow really went downhill, pun intended, and all that. And so very low amounts in the summer and much earlier than usual. That low flow meant much warmer temperatures than normal on that stream. And this is just an example of the ones that around much of the Pacific Northwest. Again, the gold dots are the average, and that blue trace is the actual temperatures. Note that scale on the right, you're getting up into the 70s. If you're a salmon, those kind of water temperatures are, you don't like that. This is a different stream, but it just happened to be one that had a nice, manner of speaking, photo from. In the foreground there is a sockeye salmon that is not getting to its spawning ground. In the background, another one with a fungus that's in pretty bad shape. Turns out there was a record run of sockeye that got through Bonneville Dam, the first dam on the Columbia, and very few of them got up to McNary Dam, just a few dams up the river. And a comment? Yeah, so for salmonids and trout, that is, you know, it's not just you get parasites or something like that. That's fatal conditions. And it turns out, here's a kind of gross little tidbit for you. It's, you know, before dinner time and all that, is that on the Columbia River during 2015, there was a massive die-off of sturgeon. And sturgeon live decades. They're scavengers. There's pretty good evidence that a lot of them ate themselves to death because there were so many dead salmon that their metabolisms just couldn't keep up with it, and you know, literally kind of blew up. There were all sorts of impacts on agriculture also. This table here, I just kind of lifted from a report done by the Department of Agriculture, and in particular, the areas of the state that are not irrigated, and there are large areas, of course, the wheat generally isn't, and pastures and so forth. And so yields were down, and there were substantial losses. At least 7 to 8% of the usual income didn't occur that year, and these are the ones that were actually recorded, and there's some pretty strong suspicion that it was probably more like a 10 or 12%, you know, kind of hurt on the agricultural community. And again, it was especially those places that didn't have the advantage of being able to irrigate. Yeah, go. So the question is about, whether farmers are changing their practices. I know that in some cases they let row crops just fail in this case. There was some, you know, I just heard some anecdotes, some stories about giving them an excuse to rip out kinds of apple trees they didn't really want anymore and plant new ones. I'm not sure how much there was a change in the type of crops. My suspicion is it's pretty minimal. And if you're a wheat farmer, boy, you grow wheat. And you know, maybe you can grow some peas or lentils or something like that. But, you know, the ability to switch is kind of limited right now, I think. At least to be able to turn on a dime. Now, of course, we can still have weather. This is a scene from the west side of the state a year ago when it was so snowy, and you know, obviously it was really cold and snowy all the way into March. And so, you know, some people get confused by that and say, okay, well, that obviates the whole thing about global warming and so forth. And suffice to say, no, we still have weather and we still have variability, and that doesn't mean that the whole idea is, you know, bogus or anything like that. All right, so let's look at some of the actual data, what we're seeing for kind of historical trends and so forth. This particular chart is from a paper published some years ago. It regards temperatures from 1920 to 2012, so it doesn't include these last few really warm years. And here for orientation, separated these columns are the winter months of December through February, March through May, spring, summer, and fall. This top row is maximum temperatures, afternoon temperatures. The bottom row is minimum temperatures. And the color of the dot refers to the trends over this 90-plus year period. The redder the dot, the more it has warmed at that place. This isn't model data or anything. This is direct weather station data. There are actually a few light blue dots where it shows that for whatever reason, there are, that place kind of happened to cool off during that period in that season. But let's face it, there's more red dots than blue dots, huh? Right. All right. One thing, looking at this, and I encourage somebody just to shout it out, does it look like it is warming up faster in the afternoons or in the nights? The minimum temperatures there, the T-mins, the bottom row or the top row? Which one? Bottom row. Yeah, right. More red there. And in particular, what we've really noticed on the western part of the state is that occurring in summer. So just as a kind of a way of comparison, if we look at, here I'm kind of mixing things around, but here looking at the winter as a whole and just the year as a whole, sorry, the water year, and the average temperature over the state, and this 100-year plus period is something like 1.5 degrees of warming. But if you focus down and look at this part of the state, and here looking at just the nighttime temperatures in summer, it's something like double that, the fitting a trend. And when you look at the kind of the noise in the climate system, the year-to-year variations, that relative to that signal, in the minimum temperatures, we're definitely seeing these trends. And again, this is something that is actually becoming part of the public consciousness on the west side of the state. And people are saying, oh yeah, it's just a little warmer at night, and it is just a little stickier. To be sure, it's nothing like Louisiana or Alabama, one of those godforsaken places that I would say is unfit for human habitation in the summertime. But it is getting warmer, and at the same time, we can actually know a little bit why that is, because the atmosphere is getting a little bit more humid also. This, for what it's worth, is the actual amount of water vapor in the air, not so much. Yeah, a little closer, yeah. All right, yeah, try to do a better job there. Thanks. Yeah, so for what it's worth, this again shows that there's an unmistakable upward trend in humidity levels. All right. Kind of oh, please. Yeah, well, this one is for the state as a whole, and we see it's pretty universal. So it's not like there's one spot that's really getting a lot more humid and other spots not so much. Yeah, I have to admit I haven't done a real careful comparison here on kind of these humidity values. The products I'm using, I don't want to get into the details here, but we're probably better able to estimate things for large areas because it's just the nature of the data. All right. Yeah, so what about precipitation? They're very much kind of a different story. The springs, the second set there, are getting a little wetter, again, over this period, 1920 to 2012. But other seasons, we're not really seeing trends emerging from the kind of the noise in the climate. And so that's yet another perspective on that. Again, I think in water years rather than calendar years. And there's a little tiny upward trend in precipitation. This is for the Northwest as a whole, but clearly the year-to-year variations are dominating any sort of overall trend. All right. There is some very tentative evidence that the very most intense rains are heavier than they used to be. There's certainly, when you look at the U.S. as a whole, that emerges. It's a real noisy data set. You can tell I made this one because it's aesthetically not very pleasing, and so bear with me while I try to explain what's going on here. What I've done for these, 5 stations on the east side of the Cascade Crest is looked at going back to 1950 through, I think it was 2015 or something, the 10 biggest one-day precipitation events. And so their timing is where these bubbles are along the time series. And then the biggest event of that gets the large circle, and all the rest of them are kind of the diameter of that circle is proportional to its ratio versus the all-time greatest one day. Again, this is summer precipitation events. And I would argue that there's more of the big bubbles in the second half of the record than in the first half of the record. But, you know, again, to give you an idea, certainly there were some heavy downpours in past decades, and it's not like every year we get really heavy events. But this is something we are seeing in the climate system, not just in the Northwest, but elsewhere. One thing we're definitely seeing, and is a theme keep coming back to, is the impacts of the climate change on our snowpack. This is a time series from a station in the North Cascades, about 4,500 feet, Beaver Pass. Others have somewhat different kind of character to them, but this is representative. And what it shows here is the amount of water in the snowpack, if it's all melted out on the April 1st of each year, going back to the 1940s and through 2015. There were bad years in the past, and there are good years in terms of snowpack, with more being more the merrier in recent years. But you can see there's no mistaking the downward trend, and then there's the disaster of 2015 right at the end. And this is, we've had some good years recently, but nothing that has reversed this trend by any means. You may recall we are having about the same amount of precipitation in winter and less snow. Okay, that means more rain, and that means that in a lot of watersheds, more floods. And so this time series happens to be a river on the west side of the Cascades, the Stillaguamish, going back to 1930 or so, showing the magnitude of the biggest flood, one day stream flow each year. And this one clearly, all the greatest floods are in recent decades. And this is something, again, not on every river, but we see a lot of them this way. And so more rain, less snow, stands to reason, bigger floods. And then just to kind of give you a more kind of map perspective here, this is a paper that was published quite a while ago, but is still basically relevant, showing the trends here in this kind of ratio between snow versus rain, with the red showing where it's an increasing proportion of rain in the type of precipitation that's occurring. And so especially on near the Pacific coast, you can see that it's less snow versus rain in that proportional sense. What, for anybody, you know, where the blue dots, where there's more snow, you know, where's that happening and why? Anybody? Yeah, so it's in the Rockies. What's different about the Rockies versus the Cascades? Yeah, a much higher elevation. And so they're not near that marginal temperatures where, yeah, it's a little warmer, it falls as rain, and a little colder, it falls as snow. It's in a lot of these places, it's almost always snow anyway. So, yeah, again, one size does not fit all. I'll just run through this real fast. Another thing related to water is demand. And the Climate Office did a little paper a few years ago looking at evapotranspiration in the Columbia Basin of Washington State based on direct data. And this particular parameter is actually how much water would come out of a field of alfalfa if it was sufficiently watered. And so what it refers to is how dry it is, how windy it is, and how much energy there is for this evaporation and transpiration. And the bottom line is that it went up in that period of where we have direct measurements from the late 80s to 2011, 2012 or so. The scale here you would say 0.03 inches per day. What's that mean? Maybe you don't, that doesn't sound too scary, but over 100 days of summer or something like that, that means conceivably you need 3 inches more of water to keep a healthy crop. And so as the climate changes, demands could well be increasing. All right, a few other factoids here. One of the things that matters is not just mean changes, but extreme events. And so here I pick the metropolis of Ritzville as a way to kind of gauge, how things are changing. And I picked Ritzville because it's pretty close to here, and because let's face it, the urban heat island effect is probably not manifest here. It's a wide spot in I-90, more or less. And if anybody's here that I've insulted from Ritzville, tough. But, so what I have in the blue trace here is just the number of really cold winter nights that get below 15 degrees Fahrenheit. I picked this as kind of a, obviously it happens all the time, but it is still a really cold night. And in these, the present climate is something like 25 days a year that occurs. And in the past, it tended to be a lot more often that you'd have those really cold nights. At the same time, I picked on the red trace there is the really warm summer nights. And some I'm going to keep hitting on here. You saw that in some of the mean. That's a real concern about what is happening to our nighttime temperatures in the summer. There, I didn't bother to fit a line through it or anything. There's maybe some hint of an upward trend, but there's certainly plenty of year-to-year variability in that too. One thing that I think is kind of interesting, we see this on the west side too, is that the number of really hot days doesn't seem to be changing too much for reasons that escape me right at the time. I picked a different spot in eastern Washington, Odessa, also, and just number of 100-degree hot days, and there it doesn't seem to be any trend whatsoever. But what can be kind of tricky about this is that is a place that is getting more and more irrigation. And so what is the land use potentially doing to that? That if we have a landscape that is, fields are a little bit more wet and so forth, and solar radiation is going into evaporating that water versus heating up the land. And so one has to be kind of tricky with, or be careful with some of this stuff. One thing that I think a lot of you can personally attest to is, at least seemingly, the increasing wildland fires in Washington State, and especially around here, just the smoke problem. The trace there, it's kind of, it was hard for me to get my grubby mitts on any sort of data going way back there. So this is a pretty short time series, but that red trace shows basically the number of wildland fires for Washington State. That hasn't changed too much. Lightning starts some of our fires, people cause some of them, but that hasn't really changed too much over that 18-year period or whatever. But the acreage burned, the brown trace, definitely has, especially considering those really bad years of 14, 15. And for what it's worth, the really smoky years of 17, 18, that was smoke from Oregon and British Columbia and so forth. And so you have maybe a bigger perspective here. You'd see, that trace being a little bit more consistent. One related to those wildfire conditions is, and just how big a problem is just kind of how long the wildland fire season is. And I wasn't sure the best way with direct data to kind of assess that, so I went back to my second favorite spot, Ritzville, and just to look at the length of the growing season there, and with the idea that the longer the growing season between the last frost and the first frost, the more the landscape has a chance to dry out. And it turns out that there is some indication that the last frost is occurring earlier in the year. You have a longer growing season then, and maybe that it's going in a little later into the fall, and so you have just that an extended fire season. All right. But you know, in the idea, you know, kind of truth in advertising and all that, and to kind of illustrate sort of the challenges in trying to kind of figure out what's going on in the climate, there's plenty of sort of important parameters that we don't see much change in. This is an example, just the summer stream flow in the Walla Walla. You might think, okay, less snow in the mountains. You know, the precip in the summer isn't going anywhere. Why shouldn't the stream flow be going down? I don't see it there. And so, yeah, it's not an easy problem. Let's get back to the ocean, where I'm more comfortable paddling around. And here is, for a box about 1,000 kilometers on the side off the coast of the Pacific Northwest. This is a time series going back to 1900, relative temperatures relative to some baseline value. And you may have a hard time believing this, but we have actually some semi-reliable estimates of what the temperatures were like out there more than 100 years ago. And even if these data are somewhat you know, prone to more errors and uncertainties, there is a slight upward trend, and then there's the blob of 2014-16, and that's why we made such a fuss about it, is because it was just uncharted territory in terms of the conditions along the Pacific coast. For what it's worth, you may have heard about Blob 2 or something. There's been some media coverage. The Northeast Pacific warmed up this summer, and the models for the spring coming up into summer are suggesting that the temperatures are going to be at about this level here where I put the asterisk. And so this is something we're dealing with more and more. So I could give you some more stats about why, you know, globally, why, you know, we think global warming is occurring, and I'll just, basically this makes the case better than I could. And so let's look more into what the models are showing for the future decades. And I should hasten to add that I apologize if I've offended anybody, and I'll take the rap. But okay, anyway, let's go. What are our models suggesting? The climate models, which are imperfect. They don't all agree with one another and so forth, but they are our best tool for kind of estimating what's going to happen in future decades. What they are showing for winter here, and this is the period of 2040-2069 relative to the kind of the end of the 20th century, the pattern of warming in degrees Celsius. They're in summer, so warming, a little bit less along the coast on the west side. Why do you think that is? Anybody? Yeah, there's a big old ocean there. There's a lot of thermal inertia there, and just like the seasons are muted along the coast, the changes in temperature. The oceans are warming, to be sure. I showed you that trace, and it turns out if you do a global energy budget, the oceans are soaking up over 90% of the extra heat out of the whole system, but there's still the change in temperatures themselves are greater over land than the ocean, and that's reflected in these kind of greater warming in kind of continental regions in the interior of the Pacific Northwest versus the coast. All right, these two plots on the right have to do with precipitation here in winter at top and in summer at the bottom. And this is the, I should have said initially, these are the models and the ensemble of the models, the all averaged together. And what they're showing is basically wetter winters, especially kind of in the north part here into British Columbia and Vancouver Island and so forth, and drier summers. These scales are different, and so the increase in precipitation in the wintertime is greater than the decrease, the modeled decrease in precipitation in the summertime. All right. And I just want to give you an idea, though, about how much consistency there is among these model projections. This is from older model runs. They're still valid, and it's just kind of a nice illustration of you know, that kind of variability from model to model. And here what is shown, there's kind of two different scenarios for what the world's going to do as a whole in terms of greenhouse gas emissions and eventually what the greenhouse gas concentrations are in the atmosphere. And these box and whiskers plots kind of show the models as a group, what they're showing, again, for the 4 seasons. And the individual models are those dots. And so you can see there's a strong consensus among the models so that it's going to be warming all seasons. But there's different models have different magnitudes of that warming. This happens to be the 2040s relative to 1917, 1999. And so we just have to deal with that uncertainty in projecting what's going to happen in the future. One important point worth making, though, that is, I think, a meaningful one, or I guess I wouldn't have brought it up today, right, is that these two kind of traces here show expected temperatures relative to a past climate for the Pacific Northwest as a whole, for the year as a whole, and it shows two different kinds of scenarios for what the world does in terms of, again, greenhouse gas emissions and other things, with the 4.5 scenario being basically now what is looking like a best case scenario. We really get our act together. 8.5 is kind of the path we're along right now. I would say it's kind of a worst case scenario, and there's some folks that think like we might run out of gas and oil and maybe even be running low on coal to really have the 8.5 happen. And so, maybe our reality is somewhere in between there right now. And the important point I want to make here is that given the continued year-to-year variations in the weather and so forth, that there's not really too much difference in what the warming is going to be over the next 20, 30 years or so, depending on what we do in that interim. The differences really starts becoming evident when you get toward the end of the century. And so this is kind of in a way too bad, because right now what you could argue, well, so something will happen that we can, we'll be able to deal with it or something. And no, even if we take, drastic action right now, it's not going to make much difference. But I would say that that's also short-sighted in that it'll obviously make a huge difference by the end of the century. So, anyway. All right. One other little tidbit about the models is here sometimes about how flawed they are, and they haven't been able to capture the observed variability in the temperatures that we've seen over the past 10, 20, 30 years or whatever. A lot of that is actually cherry picking the data, and people have definitely trying to make a point that I think is now increasingly difficult to make. For what it's worth, here from kind of historical runs of these models with past conditions. This is the envelope of their, and then taking them out into the future, this is the envelope of their forecasts. And these are the actual temperatures. This is, I picked for what it's worth, summertime and the Pacific Northwest region as a whole. And so you can, the observations are that black line. And the models are doing, they weren't suggesting that there'd be that much warming by now, and there hasn't been. For what it's worth, if you look at that in kind of anomaly form, we've had a year 2015 that is actually on the high end of those model estimates in their projections, and these are ones that projections made in 2005. And then we had a year last year that was a little bit cooler, that was kind of at the low end. But I would say at least for the Pacific Northwest, in this example in summer, the models are doing okay so far. And sure, they've got their warts, they got their problems and so forth, and they're less trustworthy in terms of precipitation. But on temperature, they're doing okay. One other, kind of perspective here, getting back to snow. Here, I want to go back to the nightmare that was 2015 and kind of put that in the perspective of what the models are showing for the future. The three parameters in the map shown here, temperature, precipitation, and snow water equivalent, how much water is in the snowpack. This, what I really want you to look at is this middle row, which was the conditions in 2015, versus the bottom row, which is the model average future conditions relative to normal in that kind of the middle of this century. And just point out that the temperature anomalies in 2015 were comparable to what the models are showing will be the mean temperatures in this future decade, and the snowpack also resembled that. So in some ways, we had kind of a dress rehearsal for what we're going to be seeing. And the problem is, of course, there's still going to be warm years and cold years in the future. And so when we have a relatively warm year in the 2050s or whatever, then it's going to be a lot warmer than what we've seen before. In terms of, again, this the idea that the models have different ideas and we have a lot of uncertainty. I showed you that they're showing as a group wetter winters and drier summers, but by no means is that a unanimous sort of opinion in that looking at the individual model results, these little dots, there are some that actually show drier winters and maybe a little wetter summers. But as we have to consider them as a group. There's no way to kind of say, oh, well, I just want to use this one. And just we have to live with that uncertainty, try to tighten up those, but some of that is just going to be inherent to the problem. What that has also, let's get back to water. That was Thirsty was in the title of this talk or whatever, and the whole idea here that Mark Twain supposedly said, and I'm not sure if it's really true, but that whiskey is for drinking, water is for fighting over, talking about the West. And that is pretty apt, I would say. And what we're anticipating is that, yeah, there are places that right now get mostly rain. That's not going to change too much. There's some places like the Yakima Basin that gets some rain, that one, mostly snow, and so it has a peak of its stream flow in the wet part of the year, but then its main stream flows in the spring snow melt or early summer. If you're a salmon in that river, you're kind of adapted. A stock there is adapted to that one, and then there's kind of snow-dominant rivers. And what we're anticipating is that there's going to be a transition from those. The rain rivers are going to stay kind of the same, but there's ones that have that kind of double peak in their stream flow will go to more to a wet season peak, and the ones that are snow-dominant, a lot of them will go to this kind of double peak one. And that could have some really ecosystem and water supply implications. So I am going to skip ahead. And I want to talk, I have a few more slides, but I want to have some chance for questions. And, you know, the idea here that we're not going to run out of water. We may have it coming at different times of year than we're used to and that sort of thing. But as long as we can prevent sort of any kind of harebrained schemes, Captain Kirk, you know, William Shatner made a serious proposal that during the big drought in 2015 that water somehow would be piped from the Columbia down to California where they had a really serious drought. You know, can you imagine the engineering challenges of that? One thing that I thought was also, I don't know how many have been to Seattle recently, but that's not the way it looks here. And whether this is some sort of weird LA version of what Seattle's like, where we live in log cabins and sell clams or something. But anyway, we will have water. But there's going to be challenges, again, with all the competing interests there. Don't want to belabor the obvious too much. And ecosystem concerns along with it, not just temperatures, but other things that can happen that obviously impact salmon, other species of concern and so forth. And I want to just spend a few minutes here about you know, some agricultural issues, coming back to that. And one thing that I think is, you know, maybe a lot of people have heard about, but maybe some haven't, is something that I thought was pretty interesting, and the whole idea about how with more CO2 in the atmosphere, which is essential for photosynthesis, of course, what that might do to water demands. And the idea here is that for some kinds of plants, and it kind of depends on the photosynthetic pathway and so forth, is that the little stomata, the little pores won't have to be as open as much with higher CO2 concentrations, and so it won't lose as much water as it might otherwise. And so just going back here, there are conceivably some more drought tolerance because of higher CO2. So some good news. For some growers, if you're growing alfalfa, getting another cutting, hey, what's to argue about that? Some increases in productivity. In some cases, if you're growing potatoes for what it's worth, that they found that higher CO2 concentrations, there's greater foliage growth, but not necessarily greater tuber growth, and the tubers grow more sugar than they want starch, and so there's some drawbacks. Wine, now that's a big deal, right? There's a paper that came out. It's gotten some criticism, but they, based on some really simple parameters, kind of these red areas are where they suggest that currently wine grapes are grown but won't be suitable to grow in the middle of this century. And that includes, you know, some regions here in Washington State, but a lot of the very high value ones in Napa, Sonoma Valley, and so forth. The green areas are where there's current suitability, and that's going to continue. And then these blue areas, where it maybe is a little too cold now, but it would be suitable in the future with expected changes in the climate. But I would submit that there's going to be some resistance to knocking down forests in the northeast part of the state. And it's not like we can or should go up there and just start knocking down the trees and putting in wine grapes. All right, just a couple more tidbits, and then again, I really would like a discussion. And that's something some of us are starting to look at, and the impacts, I skipped over the slide, is this one relates to human health, but it actually relates to agriculture too, is as the climate changes, some impacts that we can't necessarily anticipate, and in particular for agriculture, some of the things of funguses, molds, and so forth. We have drier summers. If there's fungus spores in the soil, that kind of scene is certainly going to distribute them. Other things with warmer summers, especially at nights, things like powdery mildew incidence goes up. The wine grower told me right now he's not too worried about the temperatures themselves at night going up. They need cold temperatures to have acids to have a good wine. There are no good Cabernets out of Mississippi, right? But there's some room there for it to go up. But the mildew itself, if they start getting more of that, this state grows a lot of potatoes, and right now they're prone to some zebra chip problem that is actually a bacterium that's carried by these little insects. So it's not they're chewing on the leaves, but they're carrying this little critter that causes kind of a rotting of the potato itself. And there's some evidence that these guys that are being able to overwinter that much closer to Washington State, and they'd be able to kind of, maybe more colonize the area. And then I had to put this one in. We've heard of another virus that's been in the news recently, right? But West Nile virus is here in the state. We had a fatality in 2018. California gets 20 fatalities or so a year. And I'm personally involved in a project trying to figure out just what the climate conditions that favor this, and this is getting to be more and more of a public health problem. So, just end with some takeaway points. 2015, kind of a wake-up call, a preview, whatever you want to call it, for what we're going to be seeing a lot more of. And want to emphasize that in the actual data, we're seeing, the changes more in the nighttime temperatures, still plenty of variability, and that it's about the middle of this century that we're going to see those trends get above the kind of 2 standard deviation level, that those trends, those changes will be so far above the year-to-year variability that it's just going to be, much different place. There are some resources here. I'm not going to, encourage you to write those all down, but they're stuff easy to find. And then I'm just going to finally end up with another slide for David Horsey. If I ever see this guy, I should give him just like a 20 or 50 bucks or something. I use so many of his cartoons, but anyway, there's always going to be this kind of sentiment. But I would say you ignore what's happening at your own peril. And with that, thanks. And you guys have been entirely too polite. So I want some either objections or comments, complaints especially. And so, let's have something lively.
Not a student. Students, come on. We'll wait until it gets awkward, right? I know how to do this. I'm willing.
Hi. Do you know of any research on like water towers and water condensation towers, and about how that impacts the environment around it, or so on?
So the question, if I understood correctly, the impacts of water towers, and I have to admit I'm totally ignorant. Obviously they're, would have some very local effects. There's one actually in my neighborhood about a block away, and they emptied it some years ago because they figured out, hey, if there's so many billion gallons of water up there, and we have an earthquake or something, those houses nearby, that might do a number on it. But if anybody in the room can answer the question, anybody? Yeah, hey, out of luck. All right, somebody else. We got, he paved the way for you. Very good, okay.
All right, Thanks. I was just curious. So I am interested in snowpack and things like that, and I was looking at the NIDC website to look at snowtail sites, and it looked like there was basically one in northeastern Washington, and dozens and dozens on the west side. Is there any work to improve that or improve our data tracking on the east side, particularly northeast? And then what do you think we need more data in this region in particular, in Spokane, to better understand what's going on here?
No, that's an excellent point, that the snowtail sites that are the kind of platinum standard, where you have this pillow that actually weighs how much water is in the snowpack, they're great, but there's just so many of them, and they're actually disproportionately in most of the state at too high of an elevation. They're not really representative of the full area that can get snow. And so what I'm hopeful for, and there's already some indications of kind of more remote sensing of the actual snow depth, and the Climate Office, for what it's worth, just did a little Quickie study that showed that the density of the snow doesn't vary that much. And so if you know that it's 3 feet high, you have a pretty good idea how much water there is, especially when you get at the end of the season and the snowpack is pretty ripe. And so I would think that because maintaining those snowtail sites is so costly, that to go with, maybe satellite-based LiDAR or something like that to estimate it on a real fine scale would have a lot of benefits. And I will say that this particular winter, and especially in the Okanagan Valley and just kind of north central Washington State, the upper level snowpack is in good shape, but at lower elevations, there's nothing. And there's some real concern that we may be painting a little too rosy a picture about our water resources for this summer. So thanks for the question. I guess you get one after all.
Oh, now I've forgotten. No, so getting back to this idea of your last takeaway point, how the wetter winters, drier summers, I'm thinking in terms of river runoff, the peak runoff increasing more toward March, and it being high. What kind of things can you think of that we could do to, forgive the term, redesign our aquatic ecosystems to be more resilient over the next 100 years to accommodate what you're anticipating?
Yeah, that's a great question. And, there's the chances of doing that, are kind of limited. On smaller streams, certainly kind of repairing the riparian zone, right, you're all about that one, right, and providing shade. And there's some real tests now being done, at least in Northwest Washington, by the tribes, for what it's worth, doing that and seeing how much that lowers temperatures, which can be a critical part there. If there's less water, there's less water, and that's without impoundments or some very, heavy engineering where you pump water into groundwater basins and pump it out or something. I don't know how you could really do that very efficiently. There's still going to be the changes in timing that we're going to have to deal with.
Well, I would just add that reconnecting floodplains where they've been disconnected will be really important to catch those runoffs and mitigate some of what's.
Nick, could you go back to a slide where you had 4.5 compared to 8.5 for the century? Do you know which slide I'm talking about? Yeah. I was just giving you an opportunity to talk about exactly what phenomena are happening that makes them start diverging so dramatically mid-century.
Yeah, and so, I definitely didn't talk about that, and that's a good point. is that there's kind of delayed impacts from what we're doing to the atmospheric constituency, and in part it's because 90% of the heat is going into the ocean right now, and so there's a real delay in terms of the temperatures versus what what the atmospheric concentrations of greenhouse gases are, and so that's why. To a certain extent, a lot of warming is kind of built into the system, even if we were to stop driving our cars and burning our furnaces or anything right away. And so there's certainly that part that kind of explains it, just a slow response in the climate system. And I would encourage others. I'm sure I'm missing some other aspects there to it, but it is, that's certainly an important point. And Brian, if you wanted to add to that. Yeah. Well, conceivably, but we're going to have to pay that piper, right? While I was showing some maps that showed a kind of slower warming along the Pacific coast versus inland, as the oceans continue to gain that heat, and it's mostly in the upper 1,000 meters or so, that eventually they're going to help, kind of warm and warm those coastal regions also, and for that matter, of course, most of the Earth's surface is ocean, and so the air temperatures over a warm ocean will be warmer, that much warmer too, and so, but this makes it again a really hard problem from an economics point of view, in that your benefits from action are really delayed. And so that's a hard sell when you tell somebody, you're going to have to pay, $3 more for a gallon of gas, and you're not going to see a difference for 30 years. Yeah, good luck with that one. Anybody? I bet. Oh, hey, good. I'll run it up there.
So kind of going off of what you showed on the visual about the salmon and hot water. So with all the projections that the water is just going to get hotter and hotter and the stream flow is going to get more variable, what do you see the salmon populations doing in the future, as if they're going to adapt or just go farther north, or what would you say?
Great question. So what's going to happen to our iconic salmon and so forth? And this is a good excuse for me to go back to this slide that I skipped over, where there's been some modeling of what the temperatures are going to be like on the streams across Washington State, where there's a pretty good correspondence between air temperatures and stream temperatures in summer, where it's colder on the west side in summertime. The streams are cooler, and where it's warmer in eastern Washington, streams are warmer, and it's kind of no lie, right? Yeah, pretty obvious. And as the climate warms, then we're going to have warmer streams, lower stream flows, and so forth. And so getting back to your question, a big part there is having enough wild salmon to take advantage of the genetic diversity that are in those stocks. Turns out salmon have been around for a long time, and they've adapted to big swings, natural swings in the climate. And it's not like they're necessarily going to thrive, but certainly there are probably some individuals in the present wild populations that are better adapted to what you're talking about, the future conditions. And one of the real strong reasons to kind of do what we can to maintain some of those wild runs is to maintain that genetic diversity, and hopefully there'll be some that will be able to handle it better. And you feel free to accuse me of Pollyannish attitude there, but I also refuse to kind of give up in that there are some things that are being done around the state on behalf of our freshwater ecosystems. We're improving culverts. We're folks that are traditional adversaries, irrigation districts, tribes, Department of Ecology, they're working together a little bit more. And so, yeah, I don't think we're ready to give up. And again, thanks for the question. I've already kept you here into the...
A number of people in the audience who are working on climate action plan for Spokane and adaptation plans. Is your office available to consult or help with that work at all?
Definitely, yes. That's what we're here for. And yeah, to the extent we can help, and it's a person, a full person of FTE in the office, and then it's about 20% of my time and so forth. And so it's not like we have unlimited resources, but we're happy to help. If it's an unreasonable request, we'll tell you to buzz off, and, you know, everybody's happy, right? But no, we're here to serve the public, and conceivably we do have a way to get you some of the information that that's out there. So thanks for bringing that up.
Let's thank Dr. Bond for joining